Today, we're cracking a Martian cold case, the 40-year search for life.
For years, we thought Mars was totally sterile. But what if we were destroying the evidence ourselves? Okay, so back in the 70s, the Viking landers found organics, but scientists just wrote them off as contamination. So for decades, everyone just assumed Mars was a dead, sterile rock, but a huge plot twist was coming. And that plot twist? A salt called perchlorate. Think of it as a tiny chemical incinerator in the Martian soil. See, our standard analysis involved heating the soil, which made the perchlorates literally burn up all the evidence. So those Viking results, they weren't contamination at all. They were the chemical ghosts of what we'd accidentally destroyed. To stop burning the clues, NASA sent a new kind of chemical detective to Mars. Its solution was pretty brilliant, a wet chemistry method that gently coaxes molecules out instead of blasting them. The secret ingredient was a chemical called TMAH. This was the key to getting past that perchlorate trap. And boy, did it work. The first big hit came from a clay-rich rock sample. What they found was a molecular treasure chest, the most diverse set of organics ever found off Earth. And sulfur seems to be the hero here, acting like a preservative against billions of years of harsh radiation. But the most profound find? A nitrogen heterocycle. That's the backbone for the building blocks of DNA. So, what this means is that ancient Mars had the right stuff, the basic chemical ingredients for life. But ingredients are one thing. The real bombshell, a potential biosignature, came from a different sample. Here's the deal. Life builds molecules with a pattern. It shows a strong preference for even-numbered carbon chains. And guess what Curiosity found? That exact biological pattern. A clear preference for even-numbered chains. Now, these were just tiny traces, so scientists asked, how much was there to begin with? They did the math, and the original rock could have had up to 7,700 parts per million. That's a lot. And check this out, no known non-biological process can explain that. Only an ancient biosphere fits the data. So is this proof of life? Well, not yet. The rover's instruments on Mars can only do so much. To be sure, we need to test things like isotopes and molecular handedness. Tests too tricky for a rover. So what's next? The ultimate goal, the holy grail of Mars science, is bringing samples back to Earth. Because only when we get those rocks home can we finally put this evidence under our best microscopes and solve the case.